Hey guys, you had asked the other day for an example using the square roots again with the coordinate proofs. So I'm going to go ahead and do another example, and hopefully this will help. So let's set up a coordinate proof here. Let's go, obviously, let's use the origin. It's always nice. Let's pick a point out here. I'm going to actually call this 2a, comma 0. And then up here I'll do 0, comma 2a. And we will connect those and make a triangle out of it. Let's go ABC. And we could do all sorts of things with this. We can find the mid-segment. We can find distances. We can do whatever we want. So I think actually what might be good is let's actually do the mid-segment and verify that it's really half the distance of the, that third side. So to get the mid-segment here, oops, we don't want that. To get the mid-segment here, I got to do, obviously it's going to be 0, comma something for this part. 2a plus 0 is 2a. Divided by 2 is just a. 0 plus 2a is 2a. Divided by 2 is just a. And obviously I'm on the x-axis. So my mid-segment would be right about here. So I want to verify that the mid-segment is half the length of this this third side. I don't really want to say opposite. So let's find the distance. That's ABC. So let's call this D and E. And let's find the distance DE first. Okay. So I have 0 minus a squared plus a minus 0 squared, which is, this is negative a times negative a, which is a squared. This is a times a, which is a squared, which gives me 2a squared. Now, I think this came up in the other video where we ended up breaking this apart. So I just want you to realize that. You know what this is like? This is like, what if we have the square root of, let's say 32, right? And we have to simplify that. Well, it wouldn't take long to realize that we can break this up as the square root of 16 times the square root of 2. That's exactly what we have here. This is square root of 2 times square root of a squared. Except here you see the number a squared is already, it already has a value. Well, this is really the same thing. You just got to think about that a is some number times itself. So in this case, the a would be 4, because 4 times itself is 16. This just is, you just got to keep it sort of generic. So the square root of a squared is just a. The square root, let's call that 4. So the square root of 4 squared, I'll bring that along, right? The square root of 4 squared is 4. The square root of a squared is a. It's really the same thing, except this has a value and this we have to keep general. If a is 4, then this becomes, 4. And the square root of 4 squared is 4. The square root of 10 squared is 10. The square root of 1,000 squared is 1,000. It's whatever that a value is, because you're basically squaring it and then square rooting it. Okay, so you're right back to whatever the number was to begin with. And we usually put the variable in front so people don't think it's accidentally in the square root. So the distance for DE is literally a times the square root of 2. Just like it would have been 4 times the square root of 2 if I had made a 4. Okay, so that's, hopefully, you can make that connection between an actual value and then just keeping it as a variable. Alright, now let's do it for BC. Let's see if this even makes sense with the context of this problem. So BC, that's going to be 0 minus 2a squared plus 2a minus 0 squared. Okay, did I get that on there? Yeah, that's good. So this is going to be negative, of course, times negative is positive. 2 squared is 4. A squared is a squared plus, again, same thing. 2 squared is 4. A squared is a squared. And look what we've got here. This time we've got 8a squared. So we know if we break this apart, we know what's going to happen to the a squared now, hopefully. Okay, that's going to become a. But what happens here is interesting because this is the square root of 8. That can be simplified, kind of like what we did up here. So we're just going to have to check that. So square root of 8, I'll do that up here, is going to be the square root of 4 times the square root of 2. But the square root of 4 is just 2. So this becomes, here, I'll write it down here also. Square root of 4 times square root of 2. The square root of 4 is 2. This square root of 2 I can't do anything about, and then I have the times a. I'll clean that up. I'll do 2a times the square root of 2, and as you can see, if DE was a square root of 2, and BC is 2a square root of 2, right? That's basically the same thing as this. This is double what this one is. So BC, excuse me, BC is in fact double DE using our distance formula. Okay, so just to recap, this is the part I think people were having a little trouble with. And if you can just think of it as one of the old school type of simplest radical form, it's the same concept. Same thing over here. This one ended up, you had to do kind of both because you had an 8 in there. But notice the same thing happened with this. All right, hopefully that helps. Obviously, I can answer more questions if you find a specific problem that you're stuck on, or you just think of a different type of problem you want me to do. Just ask, and I'm home now, so I can make another video if you need me to. So just let me know, okay? All right, I'll talk to you later. Bye.